A four-wheel drive vehicle suffers from poor engagement when the clutch pedal is released, causing slipping during acceleration. In this detailed workshop training video, you'll learn the professional diagnostic procedure used to determine whether the fault is caused by a worn clutch disc, damaged pressure plate, release bearing, pilot bearing, or flywheel. The video covers road testing, gearbox removal, clutch inspection, component replacement, reassembly, installation, and final road testing following real workshop standards. This lesson is ideal for automotive students, mechanics, and anyone wanting to understand manual transmission clutch repair from diagnosis to final verification. Your engine revs higher, but your 4WD barely accelerates. Is it a worn clutch disc, or a failing pressure plate? Replacing the wrong part can cost hundreds of dollars and waste hours of work. In this video, I'll show you the professional workshop procedure to diagnose the real cause, remove the gearbox safely, inspect every clutch component, replace the faulty parts, and confirm the repair with a final road test. Let's get started. Coming up, you'll see the exact inspection that separates a worn clutch disc from a weak pressure plate. Before removing any components, the technician performs a thorough road test to verify the customer's complaint and narrow down the possible causes. 1. Initial road test and diagnosis. The vehicle is driven under various operating conditions, including starting from a complete stop, uphill driving, moderate acceleration, and high gear acceleration at low engine speed. During the test, engine RPM rises faster than vehicle speed whenever the clutch pedal is fully released, confirming clutch slipping. The technician also checks for clutch pedal free play, engagement point, abnormal noises, clutch chatter, burning clutch odor, and gear shifting performance. Since clutch slipping occurs under load without transmission noise or gear disengagement, the most probable causes become excessive wear of the clutch disc or loss of clamping force from the pressure plate. The road test provides sufficient evidence to proceed with gearbox removal for internal inspection. 2. Preparing the vehicle and removing the gearbox. After confirming the diagnosis, the vehicle is parked on a level workshop floor and the parking brake is applied. The negative battery cable is disconnected to prevent accidental electrical short circuits. The vehicle is safely raised on a lift, allowing full access to the transmission. The technician removes the skid plates, front and rear propeller shafts, transfer case linkage if required, starter motor, clutch slave cylinder, electrical connectors, transmission wiring harness, exhaust components obstructing access, cross member, transmission mount, and gear selector linkage. A transmission jack is positioned beneath the gearbox to support its weight. Once all bell housing bolts are removed, the gearbox is carefully separated from the engine without placing excessive force on the input shaft. The transmission is then lowered safely onto the transmission jack and moved to the workbench for clutch inspection. 3. Inspecting the clutch assembly and related components. With the gearbox removed, the technician performs a detailed inspection of every clutch component before deciding which parts require replacement. The pressure plate is examined for heat spots, cracks, warped surfaces, broken diaphragm fingers, and uneven wear that could reduce clamping force. The clutch disc is inspected for worn friction lining thickness, oil contamination, broken damper springs, glazing, cracks, loose rivets, and signs of overheating. The release bearing is rotated by hand while checking for roughness, excessive play, noise, or binding. The flywheel surface is inspected for scoring, cracks, blue heat marks, uneven wear, and excessive runout that could affect clutch performance. Finally, the pilot bearing inside the crankshaft is checked for smooth rotation, looseness, and excessive wear that may cause input shaft misalignment. After completing the inspection, the technician confirms that the clutch disc friction material has worn below its service limit, while the pressure plate diaphragm spring has also lost significant clamping force. To ensure long-term reliability, both the clutch disc and pressure plate will be replaced as a complete clutch kit together with a new release bearing. 4. Replacing the worn components. The flywheel surface is cleaned thoroughly using brake cleaner and inspected one final time before installation. If the flywheel surface falls outside the manufacturer's specifications, it is resurfaced or replaced before fitting new clutch components. A new pilot bearing is installed whenever necessary to ensure proper support of the transmission input shaft. After replacement or resurfacing, operation of flywheel is done. Reassemble and tight to manufacturer's torque specification. Using a clutch alignment tool, the new clutch disc is positioned correctly against the flywheel while the new pressure plate is installed over the locating dowels. The pressure plate bolts are tightened gradually in a crisscross sequence to the manufacturer's specified torque, ensuring even clamping pressure across the clutch disc. A new release bearing is lightly lubricated at the specified contact points before being installed onto the clutch fork. The technician verifies smooth movement of the release mechanism before preparing the transmission for reinstallation. 5. Reinstalling the gearbox. Before reinstalling the gearbox, the technician checks the transmission input shaft splines for wear, cleans them thoroughly, and applies only the recommended amount of high-temperature spline lubricant. Using the transmission jack, the gearbox is carefully aligned with the engine so the input shaft enters the clutch disc and pilot bearing without forcing the assembly together. Once properly seated against the engine block, all bell housing bolts are installed and tightened to the specified torque sequence. The transmission mount, crossmember, starter motor, clutch slave cylinder, electrical connectors, shift linkage, exhaust components, propeller shafts, transfer case linkage, and skid plates are then reinstalled. Transmission oil is refilled if required, all fasteners are double-checked, and the clutch hydraulic system is bled whenever air may have entered the system. Finally, the battery is reconnected, and the technician performs a complete visual inspection before lowering the vehicle. 6. Final operational check and road test. With the repair completed, the technician starts the engine and confirms normal clutch pedal operation, smooth gear engagement, and proper release bearing function while the vehicle remains stationary. The vehicle is then taken on a comprehensive road test covering city driving, highway acceleration, uphill starts, repeated gear changes, and full load acceleration. Engine speed now increases proportionally with vehicle speed, confirming that clutch slippage has been eliminated. Gear engagement is smooth, no abnormal noises are present, and the clutch engagement point feels consistent throughout the drive. After returning to the workshop, the technician performs a final inspection for oil leaks, loose fasteners, and correct clutch pedal free play. Since all performance checks meet manufacturer specifications, the repair is verified as successful and the vehicle is ready for customer delivery. If you found this workshop guide helpful, please give this video a thumbs up and share it with fellow mechanics, automotive students, or anyone learning vehicle repair. Subscribe to the channel and turn on notifications so you never miss our step-by-step automotive training videos. If you have questions about clutch systems, manual transmissions, or gearbox repairs, leave them in the comments below. Thanks for watching, and I'll see you in the next workshop tutorial.